Hello guys, welcome to the day 3 of bootcamp. How are you? You guys look quite active. Mm, So today also we are going to follow the same pattern as we have to train some more CNN data and go deeper into CNN. So like we will first put on training and then we will have a quick recap of day 1 and day 2 as we did on the day one. Like we will put it on training and then we will move back to have, because training will take approx like we can say half an hour up to, because we will be doing more time, more like we will be doing more repos this time, so it will take some more time. Yes, you all can put all these code already on run all, because you might got have disconnected or you guys have closed the file from yesterday. So you guys need to run all again so it can be loaded. Uh, s- yes, please run again. And once we are done with all the recap, we will come to these question and understand what we are going to do today. In simple words, we are just going to have a brief look about what we did, like we will advance in CNN and data augmentations. Today's our objective will be like are just deepen our CNN skills, apply some augmentation to generalization of the whole model. In this, we will first like have some advancement in CNN, then we will move to documentation, and then we will also evaluate like what we have more advanced. Was not clear. Just a second. Hello. Now was it clear? Can you guys just check and tell? Still can't hear my voice. Hello. Now sound is low. Guys, now please tell it whether it is clear or not. Now fine. Yes. Now okay. So now let's proceed back to this. Only make a little bit louder. I'm speaking already. I think bit quite loud. You can just increase your volume. So once we are done with this, we will have all the discussion on this. And today we are going to also have a small quiz. In this, we will look how you guys are have understand the first day two questions, or first day two what we have implemented, how you guys have understood or not. So now moving forward, first we will put our code on training. Like first we will like depend into more what we have to proceed, and then we will have a overview of first 2 days, a very quick recap in just 5 minutes. So the students who have missed little part in the initial can have just quick recap, or who have just joined on the day 3 directly can also have recap what we have done earlier, and they can go back and do that. So starting from, like, we have to import image data generator. Now many guys, you will have question, what is image data generator? It is a tool in Keras used to create more training images, but by just like applying random changes to the existing data set what we already have. We don't have to do anything else or new. We just have to, this data generator will have some changes among themselves only, and then it is proceeded further. Now moving forward, we will data generate is equals to image data generator. We will do like some operation which we will give, like zoom the screen, or like, okay, just a second, I will zoom the screen more so you guys, is it okay now? So moving forward, like we will give like rotation. This will like rotate the image by 15 degree. Then we will have, no, we have to give just 0 point, shift range will be 0.1, and then we have height shift also we can do 0.1, and then we can also like do horizontal flip also. We will give a value as true. So if we have guys done this much, have you guys done like, what are you, what is this augmentation? I will explain this augmentation like little once we move forward. First we will just have to process some data, and I will explain this augmentation, like I have written here also question. So I will explain this in detail, that what is data augmentation and how you guys have to perform on that. Then moving forward with this, we have to like data gen dot fit, and then in we have extrain, um, and now you will guys ask what is runtime doesn't reconnect. You will ask what is c10. C10 is a Cephat and data, um, yes, done. Good evening to everyone who are guys. Attendance will be at the last, only last 15 minutes. So once we run this, it is already run. So just in simple, we can whole what we have written in this blog. like we are making more images from the same images by rotating, shifting, and like flipping them. uh, this way the model will actually, you can say, become smarter and can recognize the object in different angles, just just like we humans do. If you remember someone by like only front face, uh, and you don't remember by sideways or from its back look or from its top look, so you have to just look whole around it, so you can recognize him. If you see from any like distance from a sideways, and you have to recognize. Same way we are going to tell the model also how to recognize the images from different angles, from different povs. Okay, so now we will move forward. So moving forward, tensorflow.keras. Now we will advance in CNN. Now we will just go deeper in the CNN, so that someone is asking, sir, what is width shift range? Actually, you can say width shift range is like randomly shifting the images left or right by, like I have written, zero point 0.1. So the zero point 0.1 means 10% of its width, like what total width is, whatever its total width. We will shift either left or right randomly on its own by 10%. So now, okay, what? So the like, yes, I'm coming to batch normalization only. Uh, See, this imports what line I have written. This imports like a special layer that helps and stabilize and even speed up the whole training model. So coming just to batch normalization, it adjusts and scales the activation. Like it will first adjust all the images which we have like done in this, like we have rotated or shifted anything. It will adjust, and then moving forward, it will kind of balance them, like all in a similar consistently, like resetting, kind of resetting learning after every step. It will reset, like if we shift them, then it will reset again, and then it will do the again randomization, like which would like even help the model coverage faster and avoid getting stuck. Like if it gets any image from different angle, it won't get stuck. So I hope, when we gonna use dropout, we have already used yesterday. Further also we will use dropout some or the another where. uh, so let's, I think, move forward. So okay, What you guys are messaging? Sam getting error like exchange is not defined. Like you have to run the whole code. There is option on the above, like you can see here, run all. You have to run all the code from the above. Then it will, because you have like from yesterday you have closed your system, so it got disconnected from the whole. So you have to run this, and you will get all the, once you run all the, you will all the errors will be get removed, and you can work normally. So here, like under this, we are going to do all the pooling, convolutional 2D conversion, and flatten and drop out also, which you guys were asking. Same again in the like which we have done yesterday. In this normalization, let me smaller the screen, otherwise the code will not be visible, because this code is little bit longer. I don't think you guys will able to see whole code in this one. So once you, like same all, like first we are going to do with 32 patterns, then we are going to with 64 patterns. Same way we are like digging more. So like today, yesterday we only did till 120 60 till 64 patterns, but today we will go till 128 patterns. And again the same max pooling 2D and flatten, and then we will dense. And further we will connect all the 10, like all the 10 in the single interconnected way, or we can say. So like moving forward, we have to model dot compile, then we have optimizer is equals to Adam. I have already told you guys yesterday, it is an advanced model. And like we have to loss is equals to sparse cross trophy. And then we are going to like do some metrics also, what we kind of metrics we want is equals to like we want accuracy. uh, so I think this, once you are done you can run. There is an error like what, TensorFlow. Okay, keras dot layers it will be. Now you run again, it will, it has run successfully. Now like now in this we have to like train more data also, like we have to like do eForge if we have to go further. So moving forward with this, let's like model dot fit. We are doing data generation. Yes, this code is dependent on previous code. We have to run all the previous code once, then only, because previously only we have loaded the data. So once that data is loaded, we can move forward on that only. So what we were data gen dot, we are going to flow, then we have xtrain c10, then we will go with y underscore train c10, and then we can go with the batch size. Let's take the batch size be 32 only. So coming out of that, we have if watches. Let's take 10 efforts. Like we will let the data see 10 times. Then moving forward, we will validate data. Like validation is also validation data, and in this we what we are going to validate is underscore test with cipher 10, and then we are going with underscore test comma, oh sorry, underscore 10. I think this much we have done. So let me explain you all in very once. Like training has started. So smalling in, like here we are building a more advanced CNN, then can look a colored images also, like of 32 by 32 pixels, and it can also learn like it learns step by step. First simple shapes, then detailed, and like it is just we are moving forward, like we are teaching a kid of nursery, then first KG, then first, second, third, fourth, and moving on. Here we are normalize the activation to learn faster, and uses the dropout to even prevent overfitting also. Please share the data, sir. I will show all the code. You can pause and see there. Okay, so where and like in total where like we will like now finally we will train it smarter with smart data, after doing some rotation flippage, like we have done some data augmentation, with which we have received some smart data with some rotation and flip also. With while training with that smart data, that like slightly changed every time, like the data is always slightly changed in every time, to make the model more robust, kind of like we can say, like it will understand better everything in from different angles and every power view. So like it will take some time. Till then we can just have a whole recap of our day 1 and day 2. So I want all of you guys to be active. I think this message okay size for you guys. So starting from day 1, when okay, you guys will receive, I will try, I can't assure, but I will ask you guys only to like run all the code side by side. It will be more beneficial for you guys to understand, as this project is going to be added on your portfolio. So if you are going to add on portfolio, and if in future if you are going to give any interview, and if any interviewer asks you any question, then how will you answer him that how did it like you have executed. So if you will go side by side, you will understand what we are writing code, how it is been executed. So it's better to for your guys only. Okay, you want The last, okay. I'm waiting for 2 to 3 minutes, then we will move forward. Kindly like write quickly. So once you have done side by side, Nushulu. Yeah, I can understand it is difficult for you guys side by side, but I suggest you guys to like open live on your phone, or like if you have opening system also, then divide your system screen to two half. One half video and the another half Google Colab. Like you can split the screen, and once you split the screen, you can move likewise. Once you guys are done writing this code, please tell so we can have a quick recap. After this, we have to explain till day 3, and then we have to do a quiz, small quiz also. In quiz, you guys have to be very active, because I think in quiz partition 50 members are only limited, and the first 50 who gets to enter the code will be having facility to participate in the quiz. Others will be left behind. So this will see how active you guys are. So now let's have a quick recap of day 1 and day 2. So from starting from image recognition, what is actually image recognition? Image recognition is kind of identifying any kind of object, how its look, shape or size, etc. Then moving forward, what is deep learning? Deep learning is an advanced or advancement of kind of machine learning. Like in AI, artificial intelligence, the sub part is machine learning, and deep learning is sub part of machine learning. Moving one another in each. As we go in like from AI to ML, ML to then deep learning, it gets more advanced and complex. Then we have data sets. What is data set? Data set is a kind of collection of data. It can be number, images or anything. It can also be either structured or even unstructured also. These data is collected, and then we process on this data to like make a proper outcome or pattern, or even predict the projects. Like in this also, we are making an image recognition model. So we are using MNIST model, like sorry, data set, MNIST data set. So these data sets are help us to focus or guide us to what we want actually, or what we are going to obtain. Then what is pre-processing? Pre-processing is simple as we can like understand with the normal day to life. If you have to cook some vegetables, you have to first earlier like prepare some like clean some vegetable, then peel them off, cut into sizes, prepare the curry and etc. Same way in pre-processing in data machine learning, we have to like first clean the data, organize into a consistent way. We have to check whether there's some empty or null values or not. If there is any null values, so we have to like mm, put like we can have some value there by checking what is the mean of all the values. We can put mean, median and mode we can use, and then we can have a value there, like an approx value. Then moving forward to EDA. EDA is kind of analysis to understand what kind of data we are using, like how we are getting, how we are understanding the data, what kind of data we are having, and what other things. So moving forward with the code, here we have already installed the Kaggle API in our system, so we can directly, we don't have to like first download and then the upload the whole data set, because data sets are large. So instead of doing all that, we have just uh, installed the API of Kaggle. Then moving forward, we have just a minute. Wait, I think I have to show the screen. Mhm. Yeah, it's back. So after that, you guys have to just go on Kaggle, and the first link which appears, you have to open that. Then you guys have to sign in. You can just sign in with Google or anything. Once you guys are signed in, you will see a icon on right top side, and there you will get an option as setting. Once you get into that, you will see an option name as API. Here you will get a option create new token. So in this, you have to click on that, and a file will be get automatically downloaded as kaggle.json. So you have to just download the file and remember where it has get downloaded, and then you will just have to get back to your code. Here, this we have written to upload a file from this local system to the Google Colab. We have another option also, like we have to go here, then upload some files, etc. We have here also, but it will get locally, like all these file will get like stored in the in that specific session only. If you just terminate that session and run again, then you have to run all the code from starting. You just have to click on run all. It will automatically get on run all. Once you are done with this, you have to make a directory for the name as Kaggle, and then move that kaggle.json file which we have uploaded here into that Kaggle directory which we have made in this line. Once we are done with this, moving forward, we have to set some permissions for the Kaggle file, how we can access and everything. So once you are done with the setting up Kaggle, you just have to go back to this Kaggle and get to the main page and search MNIST. You will get a page. In this, we have to get data set. So we will have to filter out data sets column. We will just select, and the first option which you will get, data set, is this. Once you get here, you will get an option name as download, and you don't have to download whole. A code will appear here. You just have to copy from here, and once you copy, then you have to get back to your system and just paste the whole code in the next block. And once you run, it will in the file will be get stored. A whole data set will be get stored on the Kaggle input. So you can see here also, once you get, it is known as library has been set up as Kaggle input and MNIST dataset. See, same path has been stored here. So getting back to this, then we have to just do the some reshaping also of the data which we have got. First we have to understand all. First of all, we have to just check what are the shapes of the data which we have get from the data set, what kind of images they are. So here we will get to know the information about train, what the train shape and the test shape looks like 28 by 28 pixels, 60,000 images or 10,000 images, anything. Then moving forward, we have to just reshape all of them into a uh, single unified way, forming a consistent data, so it doesn't get any problem. I hope you guys are done with. Attendance will be taken at the last only. So once we move forward with reshaping, we have to look also like we are using matplotlib library here. Matplotlib library is used to visualize the data which we have got in the data sets, labeling it from 0, 1, 2, 3, 4, 5, 10, everything. We have to, it will label all the data, what kind of data it is randomly. Then once we are done with like visualizing the data, we will move forward and we will train a little bit of that data as a challenge with the Sapphire 10 model also. Sapphire 10 is an advanced model in comparison to MSG. It has got 30 by 30, 30 by into 32 image of colored images recognition also. So we will train the data set with that little bit. Quiz will be taken once I complete this explanation of day 1 and day 2. Then moving forward to CNN, you guys tell, let's see how much you guys recognize CNN. What is actually CNN? Why CNN, not others? Because if we go to a carpenter, we will not ask him to repair our electronics. Everyone has its a specified role. Likewise, CNN is used for image recognition in this machine learning. Same way, like we have other RNN also, ANN also, but we are using CNN because it is used in image recognition. Yes, to learn pattern of the images. Nice. So now, what does model training? How does model training work? This also we have covered all things yesterday. Attendance link will be given in last 15 minutes only. There is no need to spam again and again. It won't be get shared earlier by spamming. Guys, be faster. Teaching the model, yes. Sequential training with training data. Nice. Then moving forward with the question, why do we use dropout? See, dropout is just, and easily can say it is used for to avoid overfitting of the data. Like yesterday, I've given example of any first venture and a middle venture. First venture always keep on studying. His mind will just be like, only we can say kind of just ratu tuta. uh, but middle venture will have some extracurricular activities and other also which will sharpen its mind. So same way we use dropout so that a model don't over learn or over recognize an image. Yes, we prevent memorizing the data. Moving forward, how to evaluate model? We evaluate model upon its accuracy, how much it has lost the data, and considering several uh, what guys, can we use Anaconda collab? Anaconda is different, collab is different. In Anaconda, you can use Jupyter, but why to use that if you can use a web-based server? Why to put pressure on your system? What happens if over recognition occurs? If over recognition occurs, it will sometimes give error because 100% accuracy is sometimes also not good. So we will keep the kind of accuracy about 98, 99, 99.5 also. Reaching 100 might it get, like if we there's 24 hours in a day. If we just keep saying you to study for continuously 24 hours, your mind will get frustrated. Same way, we can't like give 100% data to the model. It will also get kind of frustrated. So now moving forward, we have built our first CNN here. You guys can look here. Some of the, like, you will see convolution 2D, max pooling, flatten, and dense. I kind of like suggest you guys to revise all these which I have told you yesterday, because all this is going to come in quiz today. All of this here we have like get how we have put a sequential model into this. Here people will ask what is sequential. We build CNN model in sequential way because like it is kind of layer by layer. We move our system we like teach students first primary, then secondary, then senior secondary schooling, then graduation, then post graduation, and then reaching to postgraduate, etc. So we have to like go step by step. We can't just directly jump to any level and say we because the basics will get weak. In the same way, we have to build the model also in a same way, step by step. After that, once we get to know our build our CNN data, we are going to train it. Guys, you can remember this as a hint. Model.fit, you will uh, at the end of the session you will get to know why I'm focusing on model.fit, because there's a question. And once we are done with the training, like here you can see epoch, it's the number of times data will be seen by the model. And once we are done with this, we will move forward with the like visualizing the data, like how the accuracy and training went well. Someone is asking why 100% accuracy is not good. Actually, see, 100% accuracy is like in like speaking it like it's like a dream come true. So sometimes dream come true are often seen as a red flag. If you guys understand red flag, that means you have to kind of stay away. because there are several things like data leakage, overfitting, and like imbalanced data also. So oh, if you are reaching 100% accuracy, that means your data set was too simple and your model might not get trained very well. As a high but realistic accuracy, we keep it between 85 to even 99 is also okay. But if you have a very complex data set and everything, you will get an accuracy between 85 to 95. Because if you see in chat gpt or in gemini or even perplexity or any like today's trending generative language models, you will see they always suggest that the answer is not 100% true, you can verify from somewhere else also. That's why it is said not to just only rely on ai, use some our brains also, although ai is future, but still we have to like focus on our part also. So here we just plotted the graph between the training and validation, and once we are done with this, like we will like see what the while training how much the loss has occurred, and how much accuracy we have received while storing in x text and y text. Moving forward, we have just simply done a dropout in our CNN model. See, you can okay. Here you can read also. It gives the specification. The dropout layer randomly sets input unit to zero with a frequency of rate at each step during training time, which help prevent overfitting inputs. See, Gemini is already giving its answer when we are overviewing it. So here, like same which we will have done. Yes, overfitting means it's tired like us, then it may give error. Yes, overfitting means that only, you can say. So I think this much we have till this much we have done in 2 days. Moving forward with the things like what is deeper CNN and etc. So, guys, just tell me in a short what do you understand by deeper CNN, then I will explain what is deeper CNN. No one is using more layers. Yes, Ankit has answered using more layers. Why do you guys just spam attendance? If you want attendance, then directly come at the last. What is the point of understanding and saying all this? If you are here, you are here to learn something, so focus on that. Attendance will come and you will get notification, you will see attendance link. I will also spam attendance link again and again. uh, CNN with more layers, yes, using layers to get the data of the images. CNN with more layers like convolutional pooling, fully connected, yes. Deeper CNN has more layers. This allows actually them to learn more complex and detailed pattern in images. Like once we get into more complex images, it is we then moves into deeper CNN. Like first we build a basic CNN, then we do some like dropouts and etc. Then moving forward, we are going to have uh, more deeper CNN. Just like if you teach someone to learn how to draw, you first like tell them to make lines and curves, then you tell them to build how to draw shapes, then moving forward you tell them how to draw the faces, then moving forward you tell them to like draw whole sceneries and etc. Same way each layer in deep CNN does something similar also. earlier stage detects edges and textures. Like first was like detecting the edges and textures, then moving into that like in the middle layer we will be detecting like shapes and the parts how they are looking. Then moving forward deeper into that layer, it detects the object or a whole category from which it that object belongs. Difference between a cat and a tiger. Yeah, I it can also be done. So moving to the second question, which initially many people asked, what is data augmentation? Like data augmentation means artificially increasing your data by creating or modifying the copies of existing image. Like here what we have done, like here what we have done is data augmentation. We have already a whole data set, but we have like done some rotation, then some width shift, height shift, even the flipping also. So with this we have created a new data within our existing data. Yes. uh, then moving forward with we have advanced evolution metrics. So many people might be having confusion with this. What is advanced evolution metrics? So coming to advanced evolution metrics, we go beyond just accuracy. Like till now we were just like talking about here when you come, we were just talking about accuracy and the loss. So when we go beyond like just accuracy and everything, to give deeper insight how our model is performing, especially when classes are imbalanced, like some classes more value, some has lesser. So then we go into advanced evolution matrix. Now some of the key matrices we use in this is like precision, recall, f1 score, and even the confusion matrix. Now like I will tell you what is like precision. Like precision is out of all predictive possible, like what all it has now like predicted, how many were actually correct, like out of whole, like in probability, like how does we play probability, out of 100, like we are getting only chances of 40. Same way in this we are like having how many true positives we have obtained upon the total positive, like true positive plus false positive, all the positives we have already achieved. Like avoid it is kind of avoiding the false alarm kind of. So moving forward with second like key metric of this is recall. Like recall is out of all actual positives, how many did the model catch? Just a second. Sorry guys for the gap. Now coming back, like we were on recall. So recall is out of all actual positive, how many did actually model catches? Like how many did model detected in itself? Then moving to like f1 score, many one we will be assuming like f1 score is f1 racing. No, it's not like that. It is like harmonic means of precision. It is kind of mean of both precision and recall. It can be best when you need a balanced output kind of. And then we have another matrix which we will be further showing also. It's confusion matrix. Confusion matrix is named something like it will you will see the name is also confusion, then how it's going to solve problem. No, it's actually show the correct versus the wrong prediction per class. Like if we are having 10 classes from 0 to 9, then it will show that how many correct prediction were made and how many wrong predictions were made per classes. Like we will plot a whole graph in a versus. It actually helps to visualize our mistakes only. So I think till here, has everyone's model got trained? 10 out of 10, all the epoches are done. Just message so we can get like done. I think all I have might have done with this much at least. Done. Okay. So now we will just, what you guys want first? We should first proceed with code, or we should first do the quiz? Just message fast. What you guys like first? For what first we want you do? Like first you want quiz, or the first we will code the complete the code only? Code. Okay, so we will proceed with code only. So moving with code. So now we are going to like importing, like we are going to import the tools to analyze the predictions what we have made. So here from sklearn dot matrix import confusion matrix. I have already told you guys what is confusion matrix. And then we are going to like have classification report also in this. Then we are going to import the numpy. Many of you guys have listened about numpy. It's for actually for array operations used to handle number as np. We are going to install this. Once you guys are done with this, then we should proceed like y prediction underscore c10. C10, I don't think I have to explain again what is C10. Model dot to predict. Here we are predict what we have, then what we have got under the X test C10, and then we are going like argmax. Like in argmax, if we are writing argmax axis is equals to let 1, then we are like picking the class with the highest probability of each prediction, like whichever class will be having the highest probability of prediction, and then we will be picking up that. So now moving forward with confusion matrix is equals to confusion matrix Don't spam attendance. Otherwise, I will give attendance at at the last minute only. If you guys are going to like spam attendance, if you guys are hungry, then have some snackers or eat some chips side by. So y underscore test. You guys are kind of cartoon. There's no one seeing you. You can just have your chips or anything. Prediction. Then we have prediction on C10. So then we are going to print the classification report, and this classification report we are using y test as we have stored y test C10 and the y. You guys are like continuously spamming attendance only. What are you guys going to do with attendance only? Then moving forward with all this, like you are done with this, then we can have import cbond as SNS. Then we are going to plot the figure. Okay, it's 8. That's why you guys are okay. Let's finish this just this code. Then I will set attendance, and you will then we will move with the quiz only. Just it will take 1 or 2 minutes to finish with this code. Figure size we are going to like say 8,6, and then we are going to heat map. Like you guys must have listened about heat map. It is plotted like where the density is most there it has the darkest part, and where it is not, it provides a true fmt is equals to t. Then we are going to plot x label and predicted. Then we are going to plot dot y label, and this we are going to like give the value true here. Then we are going to plot dot show, like I think this is. So in short, in this we are going to testing how well our model did, not just by checking if it's accurate, but also by looking where and how it made mistakes. The heat map shows what the model guessed or what the real answer was. uh, Greater for finding patterns in the errors also, like what kind of errors it's making. So when you are guys done with this, like it will take a minute, I think. See, it has given the precision, the recall score, the f1 score, and the support, the accuracy, the weighted accuracy. And then moving forward, here is the whole heat map for like 0 true values and 0 0 where it is prediction and the where it is giving error. It is presenting a whole heat map. I think we are done for today for the coding part. Once you guys copy this much or you are done with this much, just message done. Till then, I'm pasting the attendance. Give me a minute. Today is, I think, day 3. Yes. Mm, I hope many guys are done. Sir, can we do quiz tomorrow? No, it's a small quiz. Only I think 50 members will be. So once you are done with this, just open menti.com and I will tell you the code. And once you guys are ready, just tell like code for the menti.com will be 7267 and 6150. 6150. This is code for the Menti. Once you guys have start login, just message done so we can start when we take quiz. We are going to take quiz just now only. Tomorrow we are going to learn transfer learning and hyperparameter tuning also, like we will use some pre-trained models and optimize it for more better results. I think done. So let's start with the. I hope you guys can see my screen. Guys, answer fast. I think people are still there to join. Only 25 people have just joined the quiz till now. Guys, join faster. This is the first. We will only just have 10 questions and then move forward. Nice, you guys are answering correct. Almost all have correct. You guys are also reaching the accuracy of 99%, just like our model. It is kind of getting overfit. So I think almost all have done the correct. So moving to like just next slide. So what does convolution layer do? Initially, I got shocked when I saw the first answer. Nice, you guys are doing really good. Answer fast. Let's see how many of you guys really do. We will also have quiz on. I think if you guys want, we can have quiz tomorrow and day after. All on the last day also. You can see the code is written here 72676150. If you are guys are having problem, please wait. Net is slow. How to join? Just go on menti.com and enter this code. Yeah, you guys are very good. So the answer is it detects the features like edges and shapes in the early stage only. So now moving to the next question. Moving to the next one. Why do we use pooling layer in CNN? The code is written on the top 72676150. You guys are really answering very well. Nice. The code is already you can see on the screen on the top 72676150. Website name is menti.com. I think we should move forward. We have like only four have given the no six have given the wrong answer. Rest we have reached the 100%. So we will move forward to the next question. Why? What does flatten do in a CNN? Like we have used also. I have tell you guys earlier also. Very nice. You guys are giving the answers quite fast. Convert to D. Any wrong answers also? Yes, here comes one wrong answer. Another wrong answer. Very nice. Doing quite. You guys are doing quite well. You guys are exceeding the accuracy rate also. So let's see the answer. Correct answer. Obviously, it goes with majority. So moving to the next question. What is the role of the final dense layer with soft max? Like we have two layers, then the what is final layer with soft max? Oh, here people are getting confused. Yeah, for, this is the first question where people are getting quite confused. It looks like people are getting confused between what to answer and what not to. Again, the majority is winning. It look nice. Like it looks nice that majority have understand the concept and they are able to answer it very quickly. Now let's come to the answer of this question. As we go with majority, it is to output class probabilities. Then let's move to the next question. Now comes like most asked, most demanding question. What is the purpose of dropout? I think most example are also given of this question only. It's look like public opinion has got the right answer. Just like we say in KBC, Amitabh Bachchan says correct answer. It's nice. Like I think almost all have answered. Very nice. You guys are like doing excellent. So obviously you guys are right. It prevents overfitting of the data. So moving to the next question, what functions start training the model in KRS? If you guys remember, I have like highlighted also, like you should remember this. Yes, you guys are quite intelligent, I can say. Answer fast so we can move forward. I think few are left to answer. I think only few. Yeah, almost done. So let's see the correct answer. Obviously, you guys are quite intelligent. Some got confused with model.train, but while explaining also, I told you to remember model.fit to start the training of the carers. So now move forward to the next question. It is like I think this is going to be like answered by everyone correctly. Oh, here also some people are answering different. What does epoch 5 means in model training? It can be epoch 10, 15 and more depending upon how much you want to train your data. Okay, the bar is going up with the right answer. Some people got confused with like train 5 layers, train with 5 minutes, etc. Few are left to answer. Once the answer, so we will see the, I think almost done. So the answer is obviously reaching the 100%. Oh, 101, 102. Nice, you guys are answering quite fast and like right also. Then we have moved forward. Then what does model evaluate return? Oh, I have just moved in and already many have answered also. Few are left. Answer fast, so we will just. I think one or two questions are left. Then we will end this session. Okay, so here is the answer. Obviously, people were correct. It actually returns the loss and the accuracy on the test data. Now moving forward with the second last question, I think our last question. What does validation split 0.2 do? Answer fast. I think this is the last question only, or no, I have one more question left. Answer quickly, quickly, yes. I think almost all have answered. Few are left. Answer quickly so we can move forward. Yeah, I think almost all have answered. So obviously it uses 20% data to the test during the training. 0.2 means 20%. If it will be 0.4, it will be using 40% data and so on. If 0.1, 10% data and goes like this. Okay, we have like ended here. So I will like to end this stream here. We will get back to you guys on the day 4. We will advance to more advanced to the things like hyper tuning and etc. We will like learn how to transfer learning, and we will also be using pre-trained models like net v2. If you guys have any time, then get some research about mobile net v2, what is it and how does it work. So bye guys, see you tomorrow with the same energy.